In section 2.3, we talked about intercepts of a line. So the next characteristic of a line we're going to talk about is the slope of a line. The slope measures the steepness of a line. Just like on a mountain, if it's a very steep mountain, it has a high slope. If it's a very flat path, then it has a slope of 0. Okay, I'm going to sketch what positive, negative, slope equals 0, and undefined slope look like. Okay, when we measure slope, we measure it from left to right. So if it's a positive slope, from left to right, it's going uphill. Okay, negative slope means I'm going downhill, and I start from the left side, and I travel down. Okay, if slope is 0, then it's completely flat because there's no hill at all. This is measuring the hill. So if I make this totally flat, it's going to have a slope of 0 because there's no hill in it. Okay, undefined slope is actually slope that is so steep it cannot be measured by numbers. It's infinitely steep, so it goes straight up and down. Okay, and it's only undefined because it is so steep it cannot be measured. Okay, to measure the slope of a line, we do the change in y over the change in x. So how far up it over how far to the side it goes. There's a couple ways to express this. First, the slope of a line is usually represented with the variable m. Okay. Another way to write change in y is we use this little triangle. The triangle means delta. So change in y over change in x is the same as delta y over delta x. And you often learn in middle school that this is really the rise over the run. And remember, rise is change in y, so it's how far up or down. Run is how far to the side it goes. Okay. For example 0, you don't have to copy it because I know it is hard to copy these pictures into your notebook if you don't have graph paper. Okay. I'm going to measure the slope. To measure slope, I start from one point and I travel to another point on the line. And you normally want to use points that are at corners because it's easier to count. So these happen to have points that are already marked. I can see this is a nice point and this is a nice point. The reason they're nice points, besides the fact that they're marked, is because they're at the intersection of 2 grid lines. This one's kind of in the middle, so it would be hard to count the rise or the run. Okay, I often start with the point on the left, although it doesn't matter, so I'll show it to you both ways. This is the point on the left. If I want to travel to the point on the right, I'm going to rise and run. So to get to that point, I'm going to go up. I went up 2 spaces, and then I'm going to go to the side or run 1, 2, 3, 4, 5 spaces. Okay, my slope is the rise over the run, so it's the rise over the run. Does 2/5 simplify? No, 2/5 is my final answer. Okay, and I happen to get a positive answer, which makes sense because this line looks like it's going uphill from left to right. Okay, if I had started on the right point, that's okay. I would go down 2 and left 5. And that would be -2 over -5, and that would cancel to +2 over +5, so it would give me the same answer. Okay, I'm going to go ahead to the next line and measure the slope of that line. I'm going to use the points that are already marked. And I do like to start on the left, but again, it doesn't matter. Okay, so if I start on the left and I want to travel to the other point, let's see, I'm going to go up 1, 2, 3, 4. I went 4 spaces. I'm going to go to this side, 1 space. And I went right, so that's in the positive direction. So rise over run. Now 4 divided by 1 is just 4. So if you can divide it or simplify it, you definitely should. I got +4 as my answer. I should just glance and make sure that makes sense. Since the line was going uphill, I should have gotten a positive answer. If my sign was off, I could just go back and change the sign to the correct answer. That's the easiest way to do it. Okay, I'm going to go to C. Again, it doesn't matter which point you start with. I'm going to start with the leftmost point, which is this one. Okay, what am I going to do? I'm going to go down to get to the other point. Down 1, 2, 3, 4, 5. I went down 5 spaces, so I went -5 in the rise direction. Okay, I'm going to run to the right 1, 2, 3, 4, so +4. So my slope is -5 over 4. Does that simplify? No, that's good. Okay, I got a negative answer for my slope. If I look at the line, it does look like it's going downhill, so that's probably correct. If you had gone from the right point here, I would have gone up 5, so it would have been +5, but I would have gone left -4, and I would have had a negative on the 4. So I still would have gotten the same answer. The negative just might move around. As long as there's a negative though, it doesn't matter. Okay, let's try the last one like this. Okay, I'm gonna start from this point. If I go rise 1, 2, 3, rise 4, since I went up, positive. Let's see to the right, 1, 2, 3, 4, 5, 6, 6. Okay, so I'm gonna get 4/6, and I got a positive answer, which makes sense because this line looks like it's going uphill from left to right. But you know what? I think this simplifies. I could divide by 2 on the top and bottom, which will reduce this fraction to 2/3, which is a better answer. And actually, if I had started here and gone up 2/3, I could have counted to this point instead, and I would have gotten the same answer. Okay, we often use slope to graph a line because once I know one point, the slope tells me where I can find additional points, or it tells me the direction of the line. Okay, so for example 1, I'm going to plot the given point. This is the one that's given on example 1, and I'm going to use the slope to plot an additional point, and then I can draw the line containing both of those points. Okay, so I'm going to start by plotting the given point. So -4, 1. 1, 2, 3, 4. -4 in the x, +1 in the y. Okay, you don't need to label your point, but I am because it's notes. Okay, now my slope is 2/3, so that's rise over run. Since it's +2, I went up. Since it's +3, I go right. That's rise over run. I have to start from my point. So from this point I graphed, I want to go up 2 and over 3. 1, 2, 3. Okay, that's giving me a new point. So now I know that this point is also on the line because that's the direction of the line. I could do it again if I wanted to get more points, but 2 points is enough to get a nice line. Okay, and so I graph the line with that information. Okay, I'm going to do the same thing on the next one, just so we can see what happens when it's not a fraction for the slope. Okay, to start out, I'm going to graph the point. Okay, x is 2, y is -5. So x is 2, y is -5. 2, -5 is way down here. Okay, my slope is 3. Okay, now there's nothing wrong with having a slope that's not a fraction, but when I graph it, I do want to rise over run. So I can always put a 1 at the bottom because 3 divided by 1 is still 3. Okay, 3 is a nicer way to write it, but because I'm graphing it, I need to keep in mind that it has to be rise over 1. Okay, so from the 2, -5, I'm going to rise 3. 1, 2, 3, and then run +1 over to here. Okay, that's another point on my line, so I can mark that point. I could do it again too. If I wanted to go up 3/1 to get a straighter line, I could go 1, 2, 3, 1. That would keep me another point on the line. 1, 2, 3, 1. That would give me another point on the line. And I might make you do that, except for we don't all have graph paper. So 2 points will be enough to make me happy. Okay, one more example like this. Let's start with the point x, y. So the x is -2, 1, 2, y is +1. Okay, let's see. My slope is -3/2. There's a negative sign. Now you can give the negative to the 3 or the 2. It actually doesn't matter. I'm going to give it to the 3. If you want to give it to the 2, I'll show you how to do that too. Okay, so this is rise over run. So since it's a negative on the rise, I'm going to go down 3 and right 2. Okay, so from this point, I'm going to go down 3, 1, 2, 3, right 2, and I'm going to get a point there. Okay, now if you had chosen to do it, give the negative to the opposite place, I'm going to show you what that would look like. So say I had done 3 over -2, which is just as correct, and sometimes it's more convenient. I would rise +3, and then instead of going right, I would go left because it would be run -2. If I start from the blue point again, if I go rise 3, 1, 2, 3, left -2, okay, I end up over here. It's the same line. So either way you want to go is fine, whichever way is most comfortable for you. Once I connect this, I end up with the same line as someone else. And sometimes when I'm done, I just glance. The slope is negative. Does this look like it's going downhill? It does. So I was probably doing it correctly. Okay, now one more example. We're going to find the slope from a table. Eventually we'll also use a formula for it, but for now, this will be good enough. Okay, so for slope from a table, I need to remember that the slope is change in y over the change in x. Okay, because that's going to help me remind me how to find the slope from a table. Okay, so if I'm looking at a table, there's normally an x column and a y column, or an x row and a y row. Okay, so I'm going to first see what the change in y is. Okay, so I could start from any point I want and go to another point. It doesn't matter. So say I started from 2 and went to -1. Okay, if I start at 2 and I go to -1, I'm going down 3 spaces on the number line. Okay, so if I start at 2 on the number line and I travel to -1, I have to move 3 spaces in the negative direction. Okay, now I'm going to go to the x column. If I start at x is 2 and I go to x is 4, from 2 to 4, I went up 2 spaces on the number line. Okay, because the slope is change in y over change in x, my change in y was -3. My change in x is 2. Okay, and then that's my answer, -3 over 2. If I could simplify it, would simplify it. And it doesn't matter which 2 points you use in the table. If I had gone from here to here, it would have gone down 3, and this would have also gone up 2, and I would have gotten the same answer. So sometimes if you see that a certain ordered pair looks easier, you might want to use the easiest 2 points in the table. Okay, we're going to try the same thing with the next table. Okay, change in y over change in x. Okay, let me go to the y column. It doesn't matter which ones I start with, I'll just start with this first one. So if I go from 6 to 8, that's going up 2 spaces. Okay, now I'm going to go to the x column. If I go from 3 to 4, I'm going up 1 space. So 2 over 1 equals, if it'll divide, do divide it. So I get 2 is my answer. Okay, if I had chosen to use a different pair of points, you don't have to do it 2 ways. But if I went from 8 to 14, that's going up 6. If I go from 4 to 7, I'm going up 3. And if I do change in y over change in x, 6 divided by 3 is still 2. So I would get the same answer. So you really can pick any pair of points as long as your x and y's are matching up. Okay, one more like this. Let's see, in the x column, I'm just going to go from 7 to 5. That's going down 2 spaces. Okay, now in the x column, 3 to -2 is going down 2, 1, 0, -1, -2. It's going down 5 spaces. So I have -2 over -5. Well, negative over negative is going to turn to positive. So I'm actually going to get 2/5 as my slope. Okay, and if I plotted these points, I would get the same slope as I do from the table.